Hi, in this tutorial we're going to examine how to sketch a quadratic graph given a rule. So here's the rule, and basically when we do sketch a graph there's three different points of interest that we're looking at. Okay, so 3 points of interest, and in no particular order. The x-intercepts, now there might be none of these, one, or in some instances two, but there will never be more than two for a quadratic. We'll have one y-intercept, and we'll have a single turning point. So we might have x-intercepts here and here, we might have a y-intercept here, and we might have a turning point somewhere down here. Once we've got those, it's just a case of joining the dots, marking it in with some arrows on the end, labelling our axes, and preferably our points as well, and we're done. So let's look at this example. So I've cleared up the screen a little bit, and let's see what happens. So you might recall that the 3 points of interest were our x-intercepts. Now because there are, the first of our 3 points of intercepts were our x-intercepts. Okay, now because there are actually 3 things that we're looking at, could you please label them so that we know what's going on? Now your x-intercepts occur when y equals 0. So I'll replace the y with 0, and we'll go through and use the null factor law in order to help us actually find what's going on. So in this instance, there we go, in this instance 0 equals x minus 3 in brackets times x minus 1. Using the null factor law then, x minus 3 will equal 0, or x minus 1. Try that again, x minus 1 will equal 0. If x minus 3 equals 0, then x it follows will equal 3, or if it's x minus 1 equals 0, x must be equal 1. So we've found our 2 x-intercepts, and I can mark them in as 1 and 3, and I'll just label those points there now. Moving on, we now find the y-intercept. Now y-intercept occurs when x equals 0. So what we'll do is we will say, let's find y, but we will replace, we will replace the value of x with 0. So going back to this original equation here, I will just put in the 0 squared minus 4 lots of 0 plus 3. Now of course 0 squared is 0, 4 times 0 is also 0, plus 3. So we've got a value of 3 there for our y-intercept, and we can mark that in too. So here's our point 3, and I'll just mark that in as a 3 as well. Some of you will have picked up that of course the y-intercept is always a constant term, the other 2 terms dropping out. Our third point of interest is our turning point. Now a turning point is made up of an x-coordinate and a y-coordinate, and initially it's easiest to find the x-coordinate. So a couple of ways we can do this. We can just go to the point halfway between our two x-intercepts. So our first x-intercept is 1 and our second is 3. And of course if we want to find the halfway point, we just average them. So that'll give us 2. In previous videos we've also used the formula x equals negative b on 2a. And you can use that one, and it too will actually give you the value of 2 for your the x-coordinate of your turning point. Moving now to the y-coordinate of your turning point, all we do is we substitute for the value of x equaling 2 back into our original equation. So it'll be 2 squared minus 4 lots of 2 plus 3, which as we expand out will give us a value of negative 1. So that implies, which is this funny looking arrow here, that our turning point will equal or occur at a point 2, negative 1. And that too can be marked in. So going across to here, we put a little dot in representing our turning point, and we will mark that in as 2 and negative 1. So now we've got a series of 4 dots, the y-intercept, the first x-intercept, the turning point, and the second intercept, which we will join with one smooth sweeping line as best we can, passing through those points. Put arrows on either end of your graph, make sure you mark in your x and y axis, and we're done. Okay, thanks for listening.